Good morning, good afternoon, and good evening, everyone. Welcome to another webinar by Data Platform Geeks. My name is Rohit, and I will be your host for today. And today, I am very excited to introduce Joe Sack, who is a Principal Program Manager at Microsoft at Microsoft Redmond. He will be taking a session on Intelligent Query Processing in SQL Server 2019. And Satya Ramesh will help us with the moderation of Q&A. So eDominus Systems, a lot of you already know about eDominus Systems and its popular brands, Data Platform Geeks, of which you all are a part of. And we have the Data Platform Summit, our annual summit under it. And then we have SQL Maestros and a couple of brands under it, which I will talk about later. And Peopleware India, where we offer a lot of trainings, and Expand SMERP. So the Data Platform Summit 2018, it was recently concluded in August, and it was a 3-day conference on 9th, 10th, and 11th. We had 2 days of pre-con on 7th and 8th at Radisson Blu Bengaluru, which is a 5-star property. As you can see here, we had a humongous response at the summit. We had more than 900 people participating at the summit with, from over 16 countries and 300 plus companies. On the stage, towards the end, you can see the corporate vice president, Mr. Rohan Kumar, with the Redmond team. So we have already started working towards DPS 2019. We have announced the dates. It will be a 3-day of conference, and we will have 3 days of pre-cons this time on August 19th, 20th, and 21st. Satya will be putting down the links, our official website, that is dps10.com. You can browse all our previous conferences as well. So why should you really care? So first of all, it's about the professional education, the deep technical content by the world's best trainers, MCMs, MVPs, and Microsoft Redmond experts as well. And most importantly, it's all about reskilling and upskilling. And networking, of course. You get to interact with some of the best people, best personalities, and you get to make connections for life. And we have the world's best infrastructure at Radisson Blu, which you, of course, do not want to miss. And then DPS involves the community. So what does that mean? All the sessions that you see at the summit are put up for vote before we choose. So you get to learn what you choose. So, and DPS 2019 sessions will be put up again. So you should look forward to that. And lastly, highly curated content and disciplined execution. So go ahead. The pre-registrations for DPS 2019 are open. So you can visit www.dps10.com. I think Satya has already put up the link in the chat window. You can pre-register yourself, and pre-registration does not cost you anything. It just means that you are interested. And we will share a discount code with you, which you can apply later on and avail the lowest price for the conference. And yes, we will be launching Data Platform Summit 2019 officially on Feb 2 at the Bangalore Data Platform Day event, which is a free event, which you all can join. So go ahead and register. And at the event, we will be launching DPS 2019 and we'll share the discount code as well. So next steps, evaluate Data Platform Summit, go to our website. You can see all our past conferences, 15, 16, 17, and 18, all the sessions that were delivered by experts, and then evaluate based on that. This is the DPG core team: Amit Bansal, the founder and president; Manohar Puna, the vice president; Avnish Panchal, Vijay Mishra, Vijay Reddy, Sandeep Pani, Prince Rastogi, Surbhi Agarwal, Sakharam Shinde, and Devdutt Tanath, all regional mentors from all over India. The eDominant teams from Kolkata and Bangalore. And here you can see the DPG core team and the eDominant teams on the stage at DPS 2018 earlier. Special thanks to Microsoft for supporting us in our community initiatives. So why join DPG? You are already part of DPG, so go ahead and access all the free videos, labs, magazines, and a lot of other free resources. And we have come up with a new meetup model, which allows you to be a regional mentor with Data Platform Geeks. And not just that, you get to speak in our free events and most importantly, host DPG meetups in your own organization. So you can fill out a regional mentor form and we will get back to you. So if you have any technical questions, you can join our groups, our Facebook, LinkedIn, and we are on mobile too, on Telegram. Satya will be putting down the links. You can go ahead and join. All our webinars are recorded, including this one. So we will be pinging you once we upload all the webinars. So do not forget to subscribe. We have the YouTube channel for SQL Server Geeks, and we have a lot of SQL videos on our SQL Maestros YouTube channel. So without any further delay, let's get started with the webinar. Over to you, Joe.
Great, thank you, Rohit, and also thank you, Satya, for moderating. You can hear me okay?
Yes, perfect.
Okay, great. I'm gonna share my main screen and then just let me know when you can see everything. Let me go ahead and make this full screen. Okay. Look okay, Rohit?
Yes, yes, Joe, we can see it.
Okay, excellent. Okay, so thank you, everyone. I know for a lot of folks on this call, it's later in the evening, so I appreciate you indulging this later presentation. I'm actually connecting from Minneapolis, Minnesota, so it's about 9:37 a.m. my time here, but I really appreciate the opportunity to speak to your community. And today we will be talking about intelligent query processing in both SQL Server 2019 and Azure SQL Database. So a lot of what I'll be talking about today will cover both and is already out in both. Just a very little bit about me. I'm a program manager for the query processing feature family, and I'm embedded in the Azure SQL Database team, but the work that our team does crosses both SQL Server and Azure SQL Database. And I've been working with SQL Server since 1997, so I started doing development and consulting back in SQL Server 6.5. And have had connections with various folks in your community, including through the Microsoft Certified Master Program a few years ago. So great to be here. One thing I want to mention is I'm the program manager for query processing, but I get the joy of being able to talk about all the fun stuff and teach folks about what we're presenting and get feedback from customers, help functional specifications. But we have a huge team. And so behind the scenes, you could see a lot of different names like Georgi Georgievsky, who is the engineering manager for the QP team. A lot of folks work very hard on the features, and I just want to thank them because without them, I wouldn't have anything to talk about. So with that, we've already talked about that I'll be reviewing query processing improvements. And specifically, I'll be talking about what we're introducing both in SQL Server 2019, which for those of you who are not already familiar with this launch, 2019 we're in Community Technical Preview 2.2. And so the features that you see in green are already in CTP 2.2. And in 2017, we introduced a few different features called adaptive query processing. And I won't be talking as much about these. At the end of this presentation, I will have a link where you can find out about everything in the intelligent query processing family. One thing I also want to mention is that we'll have questions at the end. The way that I've calibrated this content, I'm hoping we'll have at least 15 to 20 minutes worth of Q&A time. So as you have questions, just feel free to add them to the queue. And then Satya can let me know what the questions are at the end, and then we can have an interactive discussion. So as you can see, we've added a lot of new features in the QP space. And originally, we went out with something called adaptive query processing, which just meant that, hey, when you're actually formulating a plan, during compilation or during runtime, can we start making intelligent decisions during execution time or compile time to react to any changes in what we anticipated versus what's actually happening? And what we found is that we wanted to add more query processing features, but they weren't all necessarily adaptive, but they were more intelligent. And so we've put this superset across all of these features called Intelligent QP. And the general philosophy behind it is that we want to have features with broad impact that improve the performance without really any work. So you should be able to bump up your compatibility level and see a performance improvement and then leave it at that. Now, I'll go over each of these features over the next hour or so. Before I do that, I want to set a little context, especially for those who are not necessarily familiar with query processing in general. It's important to, first of all, understand that our job is to make sure that we get a good enough query execution plan quickly that results in optimal execution time. So we're not saying we want the best possible execution plan. We're saying good enough so that we have a lower compile time and then an optimal amount of execution time. So one query I want to talk about just as a way to show you just a general philosophy behind our search space is a TPCH query 14, which is called a promotion effect query. And if you're not familiar with TPCH, it is a decision support benchmark. And for this query, which I've modified slightly, you'll see that it basically pulls the percentage of revenue derived from promotional parts for a specific period in time. So we have a select, we have a from where we're joining line item to part based on a part key, and we have a where clause with two different predicates that basically say, show us the data for June. Now, I picked this particular query because it's relatively simple, pretty straightforward. But even with a simple query where we just have one join and a couple of clauses in our where clause, a couple of predicates, even with that, we have a lot of things that we might need to consider. So when I'm working against line item and part, what are the structures that are available? So during query processing, if we're generating the plan for the first time, what are the structures that we can use to return the data? And of those structures, can I seek across them? Can I scan? What makes more sense? Given the row flow and the volume, do we think that a lookup would be needed or more optimal? When we talk about the join that we might use, we have a few different choices. We have hash join, nested loop, merge. Starting in 2017 and higher, we have adaptive joins. And then there's also decisions that we need to make around what we have as the outer input for a join. And we're not talking about outer clauses like the semantic requirements, but rather when you have a hash join, you might have a build phase, and that's the outer input. Also critical for nested loop operations as well, what that outer input is. So that's a decision point. And then also, do we use serial versus parallel execution, and also batch versus row execution mode, which I'll talk more about today. So a lot of different decisions, even for just this simple query right here. Now, running that query on my laptop. So I'm running SQL Server 2019 CTP 2.2, and I'll be showing you a few demos along the way so you could get a chance to see CTP 2.2. And in compatibility level 150, if I run that TPCH query, I see that my compile time, if it's an initial compilation, is 11 milliseconds, and then the execution time is 321 milliseconds on my system. And the plan that we actually result in, or we end up using, it has a clustered index, seek on line item. We end up using an adaptive join, so there's actually two different branches in the plan. We use hash match, we use parallelism, we use batch mode, a lot of different decisions. Now, is it the best set of decisions? Again, if we could optimize all day, maybe there are different variations that would be more optimal. For a simple query like this, it's unlikely, but it's possible. But keep in mind, from a query processing team perspective in Rowsstore, again, our job is minimize that compilation cost while giving you an execution time that is effective enough that you're satisfied with it across different workload characteristics. So what could go wrong? This is a bit of an eye chart, so there's a lot to see here. So you'll notice two different phases. So we have a query optimization phase, and we have a query execution phase. And this is highly summarized, so this is kind of a basic overview of what we're doing behind the scenes. But if I have a query like what you just saw, that query text is parsed into a logical tree the first time we're compiling that particular query. Behind the scenes, we might do a few different transformations, simplifications, and then at a certain point, we will have our different trees that we will want to get CE estimates for. So, and by that we mean cardinality estimation, or in general, the anticipated rows that we think will flow through that particular tree. And this cardinality estimation phase is actually very critical, because if we get it wrong, it can have a pretty significant downstream impact. So during optimization, we estimate the number of rows we think are going to flow through each operator in each tree, and we start costing these different trees. And the cheapest one is the winner and gets cached, and then we will go ahead and execute it And you see different execution phases. So we'll pull the plan from cache. Based on the CE, we'll get a memory grant. Once it's acquired, we will go ahead and execute. Now, what happens if I get this wrong? So if I have an estimate of one row that I think is going to flow through a table, but I actually get 1,000,000 rows. At this point, then, our costing is suspect because we've now costed these equivalent trees, assuming one row and not 1,000,000 rows. So now we've generated this plan, selected a plan that gets cached, that might have inappropriate memory, and then when we actually execute, we might be asking for too little memory and we spill to disk, or conversely, if I estimated too many rows, I might be hogging memory. I might have all kinds of different join strategies, join selection, order of operations, all of that basically could be off, all because of this cardinality estimation issue right here. So why does this happen? And by the way, I bring this up because as you start looking at these different intelligent QP features and look back at also the adaptive query processing features, you'll see that a lot of this has to tie into when we get cardinality estimates wrong. So common reasons. Why would we get these estimates wrong in the first place? One of the easier scenarios is that our statistics might be missing. So if you, for whatever reason, don't have statistics or auto creation of stats are disabled for that particular database, then we're going to have to make a guess. The other angle is stale statistics. So maybe my statistics were good as of 3 hours ago, but we've had a lot of recent activity. Statistics haven't been updated since then, and now we're missing some significant distributions that might have been helpful for a particular compilation. Next thing is inadequate statistic sample rate. So I might have scenarios where I have a very large table with lots of different distributions, high, low, and high and low. And when you look at a statistics object, and specifically a histogram, you'll see that we have up to 200 steps. And so it's not difficult to miss interesting distributions. And especially if we are sampling the data, we might miss those distributions and they aren't represented in the histogram. And then parameter sensitivity, parameter sniffing. There's a lot of content out there. We'll talk a little bit more about this in the future in later slides. But when it comes to bad parameter sensitivity, what are we talking about? If I have an input parameter, and that parameter is being used as part of a predicate, whether it's a join predicate or in the where clause, I might have a scenario where if I send in a predicate that might return one row, and that's the first time we have a compilation, then that plan gets compiled based on that one row assumption. Now, let's say somebody comes in with a different input parameter, and that input parameter actually results in 1,000,000 rows being returned. Now, all of a sudden, we are reusing this plan that was based on a totally different data frequency. And so this is a pretty common scenario. I will talk more about this, but it's a very common reason why we could have incorrect or mismatched estimates. And then out-of-model query constructs. This is really just a fancy way of saying areas that we have historically not handled. And so you'll see for a lot of the intelligent query processing features, we're trying to address frequently used or popular constructs that we make guesses with today. So in 2017, we introduced interleaved execution for multi-statement table valued functions. If you were to query a multi-statement table valued function, we would make a fixed guess about the number of rows, and we tried to address that in 2017. And there will be other examples of what we address today. But out of model means oftentimes there might be, it's basically not a relational construct, and so it might be very difficult to derive the actual right estimate during optimization. And so we've created different solutions to start addressing this. And the last one I just want to mention is around assumptions. So we also make certain assumptions under specific circumstances. So let's assume we think about Microsoft headquarters. The city is Redmond, the state is Washington. And if we have a table with city and state, and we have a where clause where we say where city equals Redmond, state equals Washington. Now, we all know that those two are 100% correlated. Redmond is within Washington, and if we have that in a where clause, we know of how it's correlated. But from a query processing perspective, if I don't have multi-column statistics on those two columns, in older versions of the cardinality estimator, we would make an assumption that those two columns were completely independent, that there was no correlation between them. In 2014 and higher, with the newer CE, we changed that, we softened that assumption. But again, if your data characteristics don't match some of the assumptions that we make, the estimates could be off. All right, so why should you care about all of this? This is going pretty deep, but it's important to understand it because when the estimates are off, it has a downstream effect of, most importantly, slow query response time. If I have an inefficient plan, performance can suffer. That also means that we can use resources excessively. So we could have high CPU, memory utilization, I/O. We can spill to disk. So for sort or hash operations, for example, if I'm not asking for enough memory in advance, we will spill to disk into tempdb. And then reduce throughput and concurrency. So if I have a lot of requests that are all asking for large memory grants, and assume that I actually don't need that memory grant size, during execution, we don't give that memory back. So you could end up with a scenario where I'm actually throttling concurrency, even though I'm not using that memory. And a last cost I want to mention, and it's not always brought up, is around T-SQL refactoring. So in the example of a multi-statement table-valued function, you might use that to encapsulate a pretty significant business logic, put it in one place, select from it. And if we're making an assumption of 100 rows flowing from that function, and you're getting 1 million rows, you might then need to rewrite it so that we actually see 1 million rows. Now, before we started providing different solutions, you might have to refactor it to an inline table-valued function. If that wasn't possible, because not all constructs are possible in that type of object, you might need to move it to an inline query or move it to a store procedure. But the key thing is that working around it takes time, and that refactoring shouldn't be underestimated. So this is a lot of the motivation behind the intelligent query processing feature family. So what's our strategy? Over the last couple of years, with that whole team that I showed with the slide of all the people, what we've been aiming for is to start trying to address issues during execution. And also, if there's opportunities during compilation, try to react to misestimates during compilation. Another motivating factor has been to try to address old limitations and to do that prioritize for big markets. And what do I mean by that? One of our features is called scalar user-defined function inlining. And that was a prioritization decision. So Karthik, who wrote a paper, which I'll mention later, looked at telemetry and saw that we had millions of scalar user-defined functions being used today in Azure SQL database that were executed billions of times. So when you compare that to other constructs, it was a very easy decision to say, okay, this is something that we need to prioritize. So let's start looking at old limitations and prioritize based on maximum impact. And then another aspect I just want to mention here is learning from feedback. So is there, whenever possible, is there a way for us to learn from consecutive executions and then inform our next execution based on what might have happened in the prior? And then adding intelligence to common operations. And one of the examples I'll have today is around approximate query processing. Okay, so let's get started. We'll start walking through a few of these and I'll show you a demo of each. First thing I want to mention is, okay, 2017, we introduced batch mode memory grant feedback. And this was for the problem that I mentioned earlier where if I don't ask for enough memory, I might spill to disk. And if I take up too much memory that I'm not using, I might hurt concurrency because other requests might be gated on getting a memory grant because of my larger disused memory. And so memory grant feedback, when it was introduced in 2017, was for batch mode execution. And we'll talk more about that, but essentially batch mode is a CPU optimization and execution mode that up until now has been associated with column store indexes. And so what we said here is, if you spill to disk, so if I have a query that spills to disk, then for the next execution, we will add the amount of memory that spilled to disk from the prior execution to the memory grant of the next execution, plus a little bit of a buffer. And then also for memory grant feedback, if we're wasting more than 50% memory, we will go ahead and reduce the amount of memory that we use for the next execution plus a little bit of a buffer. Now, for 2019, so CTP 2.2 is the latest and greatest for 2019, and also an Azure SQL database. If you enable the public preview compatibility level 150, we will inherently enable row mode memory grant feedback. So now, memory grant feedback that was introduced in 2017 is now basically adding support for all execution types for sort and hash operations. We have added some additional attributes as well. One thing I want to mention about compatibility level is a lot of these QP features, a lot of the QP features are behind a compatibility level for each version of SQL Server that releases, and then you'll see equivalent rules in Azure SQL Database. And the reason why we do that is we want you to be able to upgrade without regressing. With the query processing space changes, regressions can happen. We'll talk more about that. But we want you to be able to safely upgrade and keep at a lower compatibility level until you're ready to test the new compatibility level and move over. And so a lot of these features will be under 150. So I'm going to show the first demo on memory grant feedback. And Rohit and Satya, can you still see everything? I just want to do a little reality check.
Yes, Joe. Perfectly
Okay,
clear.
great. Okay. So what I'm going to do is, for a lot of these demos, I'm going to kick things off and then I'll walk things through because some of them can take up to a minute to run. So I'm actually going to kick this off and then I'll explain what you're seeing. So as I'm going to use wide world importers DW for this example. We're going to have compatibility level 150. And I'm doing a simulation of out-of-date stats. And this is for demo purposes only. And we have the select from order history where the stats are very much off from reality, joined to a dimension table. And you're going to see that we have a spill symbol. So we spill to disk. And if you look at the actual memory grant size, we ask for 1 meg. And if we look at overall estimates, this is just an example where you might have a skew. So we estimated 1 row. Actual number of rows is much higher. Now, bear with me. Sometimes on my laptop, things get ejected from cache a little bit faster, but I'm going to execute it a second time. And let's just take a look at the results. I might need to do 1 and 2 again, just in case it got ejected already, depending on the observer overhead. Okay, so count this as our first spill. I'm going to go ahead and execute this a second time. And then we're going to back up and I'm going to show you some of the new attributes. Okay. All right, so notice now for the second execution, no spill. And I'm going to go ahead and show you some of the new attributes from scratch. So let's go ahead and do this. I'm going to just clear everything from scratch. You can see what we've added. Now, in batch mode memory grant feedback in 2017, if you wanted to see if memory grant feedback kicked off, you could look at an X event. And so some of the feedback that we had was, hey, is there any way for us not to have to run an X event, but actually see in the execution plan that a spill happened? So I just cleared the plan from cache. We're starting the demo from scratch, and I just want to show you the first state. So if we go to memory grant info, starting with 2019 and Azure SQL Database, you're going to see a few new attributes. So we have this is memory grant feedback adjusted. And in this case, it says no first execution, and this was cleared from cache, or in my case earlier, it was ejected from cache. And then if you see last requested memory 0 and our granted memory is 1 meg. Now, if we have memory grant feedback enabled, and we do for 150, and it's for the same exact statement, then consecutive executions will show the status of a particular memory grant feedback state. So if I'm executing this a second time, it'll be adjusting, and you'll see this first execution, adjusting, stable, and then disabled. And I'll talk a little bit about disabled. So let's go ahead and execute this a couple more times. Okay, we got our spill. Again, this is pretty volatile on my laptop. Executing a second time, and if we go to properties the second time, we're going to see memory grant feedback, yes, adjusting, last requested memory 1 meg, granted memory 625 meg. So we learned over time, and then we can move to different states like stable. And this disabled state, just to be aware, this relates to the parameter sensitivity scenario I was telling you about earlier. So let's say we have a case where, depending on the input parameter, I might need a lot of memory or I might need very little. So if we are going back and forth and oscillating between small memory grant sizes and large memory grant sizes, at a certain point we will disable memory grant feedback for that cached plan, and then avoid just having to apply memory grant feedback in the first place. So we're not making things worse, but we're just basically saying, look, this isn't the type of workload that memory grant feedback can help at this time. Now, a few nuances. I already mentioned parameter sensitivity. If you have a case where you have very atypical parameter sensitivity, let's say once every 3 months, somebody comes in with an atypical parameter value that has a little bit of memory, and then memory grant feedback can come in and adjust the memory and help that. And then for everybody else, it's a typical amount of memory. That's where we can really help there. But I mentioned that if we go back and forth continually, we will disable it behind the scenes. And I just want to show you, we have this thing called memory grant feedback loop disabled. So there is an X event for you to see that status. Another thing I want you to be aware of, so you saw on my laptop in particular the volatility, but feedback can be stored in a cache plan for a single execution. And if you have something like a failover, or it's ejected from cache, or you have memory pressure, then we lose that feedback. And so I've definitely heard from folks where we would want to persist this. Let's say you're failing over or you're restarting, you want to persist this. And for this current version, we don't persist the feedback, but we know that this is something of value to do. And we're having lots of discussions internally about a common infrastructure that could potentially be used. Now, disabling memory grant feedback. So one theme you're going to notice across all these features is we're always going to provide an escape hatch. No matter what, given that SQL Server has billions and billions of executions across all kinds of different workload types, we have OLTP, we have hybrid, we have relational data warehouses. No matter what, in the surface area of query processing, there will be regressions. And so whenever we add a new feature, we want to make sure that there's a way for you to disable that feature as needed. So I'm providing a few different methods that you can use to do that. What you'll typically see across this presentation is that the most broad way to disable the different QP features is to bump down the compatibility level. So for memory grant feedback, if you don't want row mode memory grant feedback, you could bump the compatibility level less than 150. If you didn't want it at all, including batch mode memory grant feedback, you could set it less than 140. And that, I'd say, though, is the most extreme way to do it. I would actually recommend, if you want to leverage other QP features, you keep things at 150, and then you can look at things like database scope configurations. Like, for example, alter database scope configuration, set row mode memory grant feedback off. And then we also provide query hints. So you could, if there's a benefit overall for your workload, but there's 1 or 2 queries where you don't want memory grant feedback to kick in, we have these different query hints that you can apply. In this example, disable row mode memory grant feedback. Now, the next feature I want to talk about is table variable deferred compilation. And I will talk about it first in the context of temporary tables versus table variables. They're both constructs that can be used to store rows in a temporary state without creating a permanent table. In terms of using one versus the other, there's a lot of content out there. There are a lot of blogs from MVPs talking about when should you use one versus the other, what are the drawbacks and the pros and the cons. What we see, though, from a Microsoft perspective and a customer perspective, is that oftentimes the decision is arbitrary. So somebody might find a table variable example on Stack Overflow, and they use it as part of an initial design. And it works fine in early phases when they have a low row count. But then over time, as the rows increase, we run into scenarios where performance can be degraded. And so let's talk about a few of the qualities of what do you get in temporary tables versus table variables. So the legacy behavior before 2019 or before actual implementation in Azure SQL database, you'll see differences in temporary tables like indexes. Yes, we have indexes for temporary tables, but only inline definitions for table variables. Automatic stats creation. Yes, we have that for temporary tables, but not for table variables. Now, I really want you to concentrate on this last row, and this is the behavior of creating and using a temporary object in a single batch. So for a temporary table, the compilation of a statement that references a temp table doesn't, and a temporary table, of course, doesn't exist at that point, is deferred until the first execution of the statement. So what does that mean? If I have a temporary table and I have a population of that temporary table in my script of, let's say, 1,000,000 rows as part of my store procedure, we will wait to inform optimization about the 1,000,000 rows until that first execution. We don't compile ahead of time. Versus the legacy behavior of table variables, where essentially during compilation, we do not wait for execution. We will go ahead and compile everything together. And when we see the table variable, we give it a fixed guess of 1. Now, 1 row, and this assumption has been the case for many years. And now 1 row, it's fine if maybe you have 50 rows, even maybe if you have 100 rows in there. But when you start running into issues, if you have millions of rows or anything where the number of rows would really inform downstream operations. And I'll show you an example of this. So for table variable deferred compilation, what are we doing? We're just changing, and again, under compatibility level 150, we are just changing one dimension, which is we are doing the same deferred compilation that temporary tables does. We're not adding statistics. We're not changing anything around constraints or indexes or other areas. That's not to say that those might not be helpful, but as we were going through approaches for this feature, we wanted to minimize the risk while maximizing the benefit. And so for this first version, we are having this compilation match the temporary table equivalent. Now, let's show a demo for that. And I'm going to go ahead and hop over here. So like with the other demos, I'm going to kick it off first, and then I'll talk through it because this one could take a few seconds to run. And you'll also probably notice I have some hints that I use in periodic places. Sometimes in this disallow batch mode, I have that more so for the second example. I'm doing it so that we isolate out the examples. So all of these query processing features that you'll see are interoperable with each other. So you might actually see a benefit from one feature, and it's not even the feature that I'm actually really wanting to talk about at that moment. So I'm trying to isolate out these examples as much as possible. So for this before state, I have a query where I'm declaring a table variable, and I'm going to be in compatibility level 140, which means the feature table variable deferred compilation is not in effect. I'm declaring a table variable, and I'm going to insert rows into it. So I'm inserting 750,000 rows. And then we're going to use it downstream and using some old style join syntax here that I was inspired from TPCH on. But if we're joining this table variable to orders, one problem that we have in legacy systems is that we make a fixed guess about the number of rows that are in that line items table. Okay, so we're just now getting the result set back. Once it's finished running, I just want to show you the plan characteristics, and then we can compare it with the feature. Okay, so out of the gate, first thing to notice, and for those of you familiar with looking at plans, first red flag should be that we see thick lines, which assumes a pretty big row flow, going into nested loop operations. Now, you can sometimes see nested loops with larger row sets, but typically you don't. The other anti-pattern here is I see a key lookup. And so I see that a lot of rows are flowing through here. And if I hover over our table variable, you're going to see that estimated number of rows is 1, just like we said it would be, but actual 750,000. All right, so let's go ahead and just flip things to compatibility level 150. I'll go ahead and execute this. And again, I'm keeping batch mode out of the mix because we're going to talk a little bit later about batch mode on Rowsstore. Now, one thing to keep in mind, if you're using temporary tables already, then you're not going to see a lot of the pain that I'm describing. The prior query executed in a minute or so. This one took about 15 seconds. And you're going to see an entirely different plan. So in this example, we see, yes, still the thick lines, but we see different choices around the join algorithm. We're using hash versus nested loop. You're also seeing that we're using parallelism. And if we look at the table variable itself, you're going to see estimated number of rows, 750,000, actual number of rows, 750,000. Now that this plan has been compiled, and assuming that it stays in cache, which in my laptop is not a great assumption, but assuming you have an enterprise system and it stays in cache, with that said, if you're continually going to have populations of this table variable that are high row counts, then this plan that's cached is going to be more optimal than the guest scenario we had with the one row that you saw previously. All right, so a little bit more about table variable deferred compilation. So as I mentioned, we want to provide a method for disabling every single feature that we're talking about today, with the exception of Approximate QP or count distinct, because you can just choose not to use it. And so with disabling table variable deferred compilation, like with everything else, you have the option to bump down compatibility level. Again, that's not my favorite area to look at. And I would prefer database scope configuration. You can turn it off, and then also you can use a query hint. Okay, so moving forward, so additional scenario. So consider a case, and we have customers that we've worked with on this that we've heard from, and also internal customers as well, where they have very, very big data sets, and they need to perform operations against them, like the number of distinct order counts or the number of distinct elements over a time period for a very large result set. And oftentimes with these applications, there's dashboards, and the dashboards don't necessarily need exact values. They can use approximate values. And sometimes in a case of one of our internal customers, they actually built their own function for approximation. And so in a case where you are looking at a dashboard curve, let's say you're populating visualization, you don't need the exact value, but you just need the general direction and general magnitude. Or another scenario that we've been hearing from customers on, and also internal customers, is around big data set exploration. Needing to explore the data quickly. You don't need the exact values, but you need a way to just quickly get in and see what are the data distributions, unique elements across different categories and attributes. So we introduced for 2019, and then also for Azure SQL Database, a prox count distinct, and this is our first entry into the Approximate query processing space. And again, this is for fast data exploration for scenarios where approximate values are okay, where you want a very low memory footprint. And I'm going to show you an example of this. Now, syntax is very easy. This is just a little blurb from books online. Let me show you an example of this. Okay, so I've got both of these will run pretty quickly. I'm going to run under compatibility level 150, although, again, this is a little bit different because you can decide to move from a count distinct to an approx count distinct. It's not bound to the actual compatibility level. So let's go ahead and execute select count distinct order key. All right, so this is our before state, and I have my included actual execution plan. Now this is for our exact value, and this will take a few seconds to run. All right, so first thing I want to point out, we have 15 million rows. This is the exact value. So if you have a banking application or an area where you must be exact, this is the exact value. And then the execution plan isn't that noteworthy, but the one thing I want to point out is the memory footprint. So we see memory grant size is almost 1.5 gigabytes. All right, so we needed enough to deal with these distinct elements, pretty big footprint. Now, if I'm the only person on a system, then it's fine. So I could just run my query, get the big memory grant, no problem. Now, imagine you have that dashboard app I was telling you about, and let's say you put that dashboard visualization in the startup screen for everybody's login, and you have many people logging in at the same time, and they're all now executing this query, assuming it's not being cached. They're executing this query at the same time. Well, now you might run into gating of the actual queries that are trying to log in because of this memory grant request. With all the big memory grant requests, you might end up with the resource semaphore waits, and we'll have to wait until you can get your actual grant. Now, contrast this with the prox count distinct, and we'll get into some of the algorithm nuances shortly, but I'm just saying a prox count distinct order key from line item, and we'll go ahead and execute it. And I think it will shave off a couple of seconds, and then if you look at the actual value, what we're generally saying is that we'll be within 2% of the actual value 97% of the time. And you see we're almost 15 million. Again, this is approximate. And one other big thing, and this is kind of, I think, the most material difference, is look at the memory grant. So a much smaller footprint. So if we look at the memory grant size, 12 meg versus 1.5 gig. And how are we achieving this? So our engineer Parag, when he was putting this together, there's a publicly documented algorithm called hyperlog-log. HLL for short, and it's a probabilistic function that allows you to get very good approximations for scenarios where it's big data and lots of different distinct values. So that's the general rule of thumb. So I would also say, while it might shave off a few seconds for performance, also consider scenarios where you want that lower memory grant footprint. Now, a few details. Prox count distinct candidate workloads. I have to just reiterate this. It's not banking applications. It's not anywhere that you need the exact value. And I already mentioned, it's for big data scenarios, many distinct values, millions of rows to billions, and also mentioned the error rate. All right. So moving on to the next area of functionality for intelligent query processing, we'll talk about batch mode on Rowsstore. But before I get into those details, I want to really just talk about batch mode in general and how we've historically bound this to Columnstore. So SQL Server 2012 is when we released Columnstore indexes and batch mode. Now, for those of you unfamiliar with Columnstore indexes, that was a way to access just the data that you needed for relational data warehouse type workloads. And it's very compression friendly. So if I'm storing data in a column basis, so like let's say I have a department column and you're storing all the department data together over 1 million rows. For relational data warehouses, this can be very, very compression friendly. So you notice right here where I show I/O for Columnstore indexes and CPU for batch mode. So for Columnstore indexes, we have the compression friendliness. You're only pulling the columns that you need. So if I'm just referencing a couple of columns from a Columnstore index out of a very wide fact table, for example, or dimensions, I'm only pulling those columns that I need. So we have the I/O benefit there, as opposed to when you're pulling from a data page where you get all columns each time and across all the different pages that you might be pulling. Now, in addition to this, we introduced batch mode, which can work with 900 or so rows at a time that get pulled from, historically, Columnstore indexes. And essentially, if you think of our pre-Columnstore model, when a query is processing a row, it's at a CPU level, we're processing one row at a time. And with batch mode, what we're enabling here is the ability to reduce the number of instructions needed for a larger set of rows. We have 900 rows. We can apply the instructions against those rows in one batch. And again, built for analytic work scale. So we've always bound these together, but there was no reason why we couldn't necessarily separate them out. It's just how the feature has progressed, or the set of features has progressed. One thing I will mention, over time, community members have found ways to get batch mode in their relational data warehouse or their analytic type queries without Columnstore indexes, or they might do tricks like they add a filtered index to a Columnstore where it could never evaluate to true. And sometimes that's enough to get batch mode into the mix. But traditionally, we bound them together, and now we are providing native support. And one scenario when we started to see people do workarounds to try to get batch mode, it led to other questions like, well, why can't customers use Columnstore? Now, sometimes you might have OLTP sensitive workloads. So if you add the Columnstore index, maybe it impacts your throughput for your OLTP requirements for the database design. Another common reason is vendor support. Maybe the vendor that has offered the schema and software package isn't keeping up with the latest features that are being introduced in SQL Server, and so you just can't add it without breaking your support contract. And then Columnstore interoperability limitations, like if you need things like triggers, cursors, persistent columns, maybe those are reasons why you can't use Columnstores. So in 2019, we are introducing batch mode on Rowsstore, which means we don't require Columnstores in the mix to leverage batch mode. And basically, this adds native support, and I'm emphasizing native because if you're using any workarounds today, you might see some performance benefits of those workarounds, but this is actually native to the SQL Server engine and storage engine support for batch mode for heaps and for B-tree indexes. And then existing support for or support for our existing batch mode operators. So if we support batch mode for specific operations, and if you look at the actual documentation today, you'll see a long list of different things that we do support. If we support it for Columnstore, we're trying to support it for batch mode on Rowsstore as well. There's more on the subject, but I do want to just show you a demonstration of it so we can follow along a little bit. All right, so I'm going to use a form of the TPCH benchmark database, and I'm going to use compatibility level 150. And this is going to be our before query, so I'll kick it off now because it can take half a minute to a minute. And I have a use hint disallow batch mode so that we can see the original state. And this is a relational data warehouse or analytic type query, so we're going against a lot of different rows. We're doing aggregations. And by the way, so at the end of this presentation, I'll be providing the deck, of course. And then if you go to aka.msiqp, while this is running, I'll just show you this. There is a reference on everything we're talking about today: intelligent query processing in SQL databases, and a lot of different references here. But one thing I just want to point out is that I'm accumulating demos here on this page. So we have a demonstrating adaptive query processing from our original demos, and then intelligent QP. So that'll lead to some demo scripts that you can use because a lot of people don't necessarily have access to a TPCH workload. So I choose some databases that are freely available and you don't have to generate from scratch using another tool. All right, so this took about 51 seconds. If we look at the execution plan, I just want to point out, like if we hover over clustered index seek, you're going to see, as we expect, this is storage Rowsstore. So we're not going against Columnstore. And our actual execution mode is a row, as we would expect. So this is the standard behavior for this analytic type query. Now I'm going to rerun this query again, and I'm going to remove the disallow batch mode hint, and we should be able to shave off a few seconds. Now, one thing to realize about batch mode, we'll go over some of the rules, like how are we actually deriving whether or not we should use batch mode. Okay, so we shaved off a few seconds as I mentioned. If we go to the execution plan, doesn't look too different, but just if we look here at this example, storage is Rowsstore, and then actual execution mode is batch. And again, what are we doing here? I just changed this to compatibility level 150. There are some nuances here, and I'm going to go through them so that your expectations are properly aligned. But that was all I had to do to for this particular workload, use batch mode. And I didn't have to do any tricks or any constructs that would force batch mode without the Columnstore. Now, let's go ahead and go back to the slides. So what are we doing? When I submitted that query, we basically have a two-phase process, and that's a simplified view of things, but we have two different phases under compatibility level 150. First phase is that we do a rough check. So while it's still in the estimation mode, so remember that visualization where I was showing you we had logical trees and then we do CE estimation. So at the point that we have our logical tree and estimates, we do an initial check to go, should we even be considering batch mode on Rowsstore? Should we open up that search space to look for opportunities? And so we do a rough check of, we have heuristics that basically look at table sizes, operators used, estimated cardinalities. And then if we pass that gateway, then during optimization, we will start considering batch mode alternatives. So if we think that batch mode for a particular Rowsstore equivalent looks interesting, we will go ahead and explore. Now, as we explore and we see cheaper plans for the query, if it makes significant use of batch mode, we will select batch mode for a particular set of operations. If it's not significant enough, though, we won't end up using it. So we'll stop exploring different alternatives at a certain point. So why are we doing this? We want to make sure that we are mindful to apply batch mode to the right types of workloads, and we want to apply it where we have batch mode strengths and not necessarily just apply it brute force against any query that's coming our way. I'll mention this a little bit later as well. There's an email address. I'm on the distribution list for it. It's intelligentqp@microsoft.com, and you'll get this in the deck as well. And other folks on the QP team are on this distribution list. And feedback that we're going to be very interested to hear about is if you have an opportunity to test this, which I certainly hope you do, either in Azure SQL Database or in SQL Server 2019. If you test it and you find scenarios where batch mode on Rowsstore doesn't kick off and you would expect it to, or it kicks off where you didn't want it to, we would love to hear from you on those scenarios. Those examples would be helpful to us while we are still in public preview, because we still have an opportunity to calibrate heuristics. So the other thing to keep in mind, so when people talk about batch mode, they continue to, and naturally so because we've always bound them, they will bind that to the column store concept. But it is really important to think about, okay, am I IO bottlenecked or am I CPU bottlenecked for my analytic type workload? If you are IO bottlenecked, batch mode on Rowsstore isn't necessarily going to help you. Now, if you're CPU bound, this is where batch mode on Rowsstore could be helpful. And so when we recommend this feature kicks in is when you are CPU bound and when you have some of the things we already talked about, some of the limitations. Either you can't create a column store because it adds up too much overhead for transactional workloads. It isn't feasible because your application support, or there's actual features that aren't yet supported with column store that you need to leverage. That's our real sweet spot for optimization of this feature. And as with the other features that I've talked about so far, you can disable batch mode on Rowsstore through compatibility level, through database scope configuration, and then also through query hint. And a few considerations. So I have 2 slides on just some things that we've heard from customers as they've done early testing, both in private preview and now in public preview. So first of all, no guarantee that query plans will use batch mode. So when you have compatibility level 150, and you pass that first set of heuristics where it looks like it might be an analytic type workload at a very basic level, that still doesn't mean that we will necessarily use batch mode. We are trying to choose it appropriately based on estimated costs. And so there's no guarantee that if you get a row mode plan, also it will be the same as what you would have gotten at a lower compatibility level. So if we opened up the search space for batch mode, that might have led us down a certain path of optimization decisions. And so under 150, as you would expect with any different change with a database compatibility level, you might have a scenario where you see a different plan for row mode. And then also, even with a column store index, there's no guarantee that you would get the same exact batch mode plan under 150. And then also, if you have a mix, so you could have a mix of column store and row store indexes, you might also see subtle ways that the query execution has changed, or the actual execution plan has changed. And then a few other considerations. So the current limitations for batch mode on Rowsstore scan, it won't kick in for in-memory OLTP, and it won't do it for any kind of index other than on-disk heaps and B trees. And then a couple of other things on the slide, like it won't kick in for lob columns and sparse columns, that's XML columns. And then if it's not supported with Columnstore indexes, so if there's a batch mode version not supported with Columnstore indexes, we aren't adding that support for batch mode on Rowsstore. Okay, so next one I want to talk about, and then I do want to save some time for questions as well, because I see some queuing up. So T-SQL scalar user-defined functions. We'll talk about scalar UDF inlining. We have a team they basically are our engineering team in Madison, Wisconsin, that partnered with our query processing team in Redmond, and they drove the majority of this work and wrote a research paper about this. And so we're going to talk about their feature. First, I want to set the context. So T-SQL scalar user-defined functions, what are they? So they return a single value. They're written with Transact SQL. And they are an elegant way to encapsulate your code in one spot, make things modular across queries. If I have a sophisticated financial model and I don't want any variation in that model, I want to make sure that there's only one way that people do it and everybody refers to that scalar UDF in the same place. That can be a very effective way of doing that. Now, some computations can be easier to express in an imperative form. So developers tend to like T-SQL scalar UDF functions because they're a little bit easier to go step by step within the function body. And then also it removes that complexity from your select statement. And we'll show an example of this. But essentially, you can build up complex logic. So especially if you're a beginner Transact SQL developer, it can be nice to say, okay, let's put this logic someplace else and then keep our select nice and clean and everything looks easy, but there is a price. And now with that price, by the way, this is not new information. This is, we have MVPs and community members that have been talking about this overhead for years. When Karthik, who was working on this feature heavily, was doing research, it was not hard at all to find anti-patterns and reasons why it can be problematic to use scalar UDF functions. And I'll list a few of the main reasons. So first thing is, if I have a select, and I'm going to show you an example of it, and I'm selecting 1,000,000 rows. Well, if I'm referencing that scalar UDF function in my select, it's iterative invocation. So we're invoking it once per qualifying row. Now, if my function just does a simple expression, let's say I'm dividing by a number or doing a calculation, maybe that's not such a big deal. But it can be even worse if your UDF is referencing other SQL queries. Let's say for each and every invocation, I'm selecting from another table, and that table has a lot of rows, and it's not selective. All of a sudden, you have a lot of overhead that is hidden within the body of that function. Now, since functions were originally introduced, there's also a lack of costing. So they're not costed realistically. So we underestimate just what impact might occur from that particular scalar UDF operation. It's interpreted execution, and basically that just means that, you know, if we have a bunch of different statements that are compiled, they're compiled separately, and there's no cross-statement optimizations that get carried out. And it doesn't allow intra-query parallelism. So all of a sudden, we're having a serial invocation or execution just by using that scalar UDF. So scalar UDF inline, and again, the team's been working on this very hard in Madison, Wisconsin. They basically looked at this space and said, you know what, there are scenarios where we can take imperative code and translate it to relational equivalence. So they can look at when a query calls a UDF, look at different regions, and then translate the regions into relational equivalents. And then all of a sudden we can get around a lot of the issues that I mentioned in the prior slide. Now, just like with these other QP features, that's going to be under Compatibility Level 150. If you want a deep dive, here's just the name of the paper, Freud Optimization of Imperative Programs in a Relational Database. And one quote from that paper, just to show you a couple of examples. An example of imperative statement. So if we think of a declare, a relational equivalent might be a select. Or if we look at an if-else, that could be translated to a select case. So there are a lot of different scenarios where we can make this translation And then the result is significant performance improvements. So let's, before I get into the details of what the candidates are, let's go through an example. So I'm going to just hop over here. Now, I'll use the TPCH database, and I'm going to create this function, and I'm going to do it right away, and then I'll talk through it because this one could take about a minute and a half, 35 seconds without watching, but let's see here. So including my execution plan. All right, so let's walk through this while it's executing. So first of all, I'm running at 150. I have this function, and I'm calling it calc average quantity by part key. And I'm taking in an input parameter of part key, and I'm declaring a quantity. So within the body of this, I'm declaring a quantity, and I'm saying, okay, show me the average quantity based on the part key that I provided in the function call, and then return that quantity. Okay, so this is executing right now. Return that quantity. All right, so now how am I referencing it? So there's the concept of we have our function definition, but then now I'm referencing it in an actual query. So I'm selecting from line item, and I just have inline this calc average quantity by part key, and I'm taking in that part key as an input parameter. And I have my disable T-SQL scalar UDF inlining, because remember, we're under 150, and I don't want this to kick in. I want to show you the before state. So let's say you get a call at 2 in the morning, and you're responsible for looking at production, and somebody says this query is running horribly. So I normally, I just released this into production yesterday, and it's causing extra problems. Can you help tune this? And in the middle of the night, you go ahead and look at the execution plan. You get an example of the query like I just executed. And here's our simple query execution plan that references the scalar UDF. Now, at 2 a.m., your natural temptation is to look at this part. So you're immediately going to go, oh, I'm missing an index. And then maybe, and you wouldn't be blamed for doing so, by the way. So like you would look at this and go, okay, this looks like a likely candidate. I'm going to add this index and see if things run better. And you might be aware, oh, it looks like it references a function, but look at this, it's just 0%. And everything else looks, pretty serene, looks like a pretty straightforward and simple call. And of course, we would be wrong, right? Because we're doing much more than that. Yes, we are. This actual query is simple, but remember, for each and every one of these rows, we're running this average quantity, again, from line item. And you might also be asking, can I actually rewrite this so that I just inline it myself? Absolutely. But remember what I mentioned earlier, where people like the simplicity of moving any kind of perceived complexity to another function, or moving it off to a function. And so in this scenario, yes, we've simplified how this query looks, but we've added the legacy issues. So, all right, now let's go ahead and re-execute it. This time I've removed the hint, the disable T-SQL scalar UDF inlining hint. And again, the idea here is 4 function definitions that have the supported candidate attributes, which we'll go through what's supported and what isn't supported. We can translate them to relational equivalents. That will help with overall performance in a lot of cases. And if we look at the execution plan, it's totally different. We still have that missing index notification, but notice all the complexity is no longer hidden. So we've translated this to a relational equivalent, and now we're getting things like parallelism. You're able to see everything that's going on. Just as a note, by the way, so we see a spill here. If we have recurring spills, memory grant feedback could then be applied in the mix. So everything went from being opaque to being quite visible. So now if you're getting called about this at 2 in the morning, assuming that it's still performing badly even after this optimization, the complexity is not hidden. Okay, so let's hop back here and let's talk about the candidates. So in terms of the pool, so normally you'll see with features that we roll out, we will roll them out incrementally. Certainly, like Columnstore indexing was an example of that. We released it in 2012. It had specific limitations that were pretty significant. And then for each and every version, we got better and better, and we added more and more. Now, the team that worked on scalar UDF inlining, they really, I think, and this is just my opinion of seeing SQL Server over the last, 21 years or so, I feel like they really came out of the gate with a huge amount of surface area, much more than we typically can achieve within a product cycle. And so what we're finding with private preview testing and discussion with customers now, once it's gone public preview, is that if somebody has, for example, we had one banking customer, they had 100 different UDFs, we were able to help 98 of them. So first version candidates, things like declare, select, if else, return, UDF, and others, those are all supported constructs in your function. Non-inlineable, so we have a few different things that may or may not be by design that you want. So for example, if you're invoking an intrinsic function that's either time dependent or has side effects, we're not going to inline it because you might not want us to. And then also another one that I think might be more common, actually the two ones we're hearing the most about, and I totally, I would love to hear feedback if there's scenarios that are missing today that you think are critical. Again, email intelligentqp@microsoft.com. But one of the ones we hear a lot going, hey, could you add support for this, is computed columns or check constraint definitions. And then also using the scalar UDF call in a group by. That seems to be pretty common. But again, would love to hear from you if there's additional scenarios that you think should be part of this. Now, some nuances. So to inline or to not inline, if you look at sys.sql modules, that's a catalog view that has a property called isInlineable. And if you see a 1 next to it, it means that it's inlineable, 0 otherwise. And you're also going to see a 1 for inline table valued functions as well. So just note that it's not just for scalar UDF inlining, but also inline table valued functions. Now, just because a scalar UDF is inlineable doesn't always imply that it will be inlined. So SQL Server decides this on a compilation of per query per UDF basis. So there are cases where if the definition is super nested, we do support nesting for scalar UDF inlining, but if it's excessively nested, and I don't think we're documenting the exact threshold, but it has to be very, very deep, then we might decide not to inline. And then another example might be that the UDF in a group by clause. And so that's a case where, okay, maybe the UDF is inlineable, but the way that we are referencing it is not. Just like with everything else I've been mentioning, there is a way to disable it either through compatibility level, database scope configuration, disabling through query hint. And there's one other nuance I just want to mention here, and that is in your definition, you can actually say with inline equals off. So you could say, look, I don't want it to be inlineable. And we do have cases, we have heard cases where, look, one common case is the two wrongs make a right. So let's say you have a very complicated query, it references a scalar UDF, and it references some other practice or construct that has inherent issues in getting good cardinality estimates. In that scenario, we might have two bad things that inadvertently result in a good estimate, and now you have good query execution time. And then if we fix one half of that equation, then all of a sudden we have hurt the balance of it and we regress. So we provide a few different options here with that in mind. Okay, and I believe I have about 16 minutes left. Satya, Rohit, can you confirm, because I just want to calibrate on these last couple of slides.
Yes, Joe. We have
okay,
16.
Great. Okay, awesome. Okay, so just wrapping up, and then I definitely want to get to questions, and anything we can't get to, I would love it if you emailed me. But going over all these features, to me as a PM, the most important thing is I want to get your feedback on it. I would love for you to try these out. I realize that sometimes it can be a little esoteric, but if anything, notify, like if you were informed by hey, we use table variables a lot, or scalar UDF inlining, or we've always wanted batch mode, but we can't use it because of Columnstore. If any of that resonates, then please, by all means, I would love it if you tested things out. And then again, we want to hear about situations where something didn't kick off and you thought it should have, or it did kick off and you don't think it should have. And it's all in public preview right now. Now, I have a few open problems, 2 more slides left, and then questions. But I want you just to be aware that we have lots of discussions about a few different areas. So we haven't fixed everything yet. This is not a roadmap slide. Business priorities change, or there might be other things that pop up to the stack for query processing. But I just want you to be aware that there are 3 areas that we know are problematic that would be good to address at some point in the future. The first is the fact that in 2014, we introduced a new cardinality estimator model after many years of the legacy CE model being available. And we've learned over time, over the last few versions, that one size does not fit all, and that there are scenarios where customers can benefit or not benefit or regress, and that it really just depends on how you're using SQL Server, your data distributions, how things change over time, your design patterns, your schema. And so we know that one size fits all. So with that, it wouldn't make sense for us to create a new CE, but rather continue to invest in adaptive and intelligent query processing features like we've been doing. But CE models are definitely something that we're thinking a lot about. And then also parameter sensitivity, optional parameters. I already talked about, the parameter sensitivity problem. Optional parameters, kind of a variation of that, or what we call internally a structural issue, where if I send a parameter value, and depending on that parameter value, if I send it or if I don't send it, we have 2 different execution plans. So you might have a predicate where it says, if the column or the parameter value is null, then we want to basically return all rows from that table. And if the column value is actually explicitly stated, then we want to seek on that value. That's actually a very common pattern. And we know this is a pain area that customers are looking for help on. And then last area is just we know about the stats, quality, richness, and breadth. So as you get larger and larger result sets or data distributions are more and more jagged, we know that it's important to be able to represent in this compact format what are your data distributions without losing key distributions in the mix. So those are all areas that we haven't forgotten about. Again, no promises, not a roadmap, but just trying to represent, what are other problems that need to be solved over time. And then last thing I want to mention beyond the intelligent QP at Microsoft.com is here's the short link for the main reference, aka.msiqp. So I think that leaves us 12 minutes for questions. And of course, you can email at any time. You'll have the whole QP team on there for questions. So let me actually escape this slide deck. And then Satya, did you want to call out the questions, or do you want me to actually pull it up myself and then start going through them?
Yes, Joe. So before we take Q&A, Rohit has a few slides to cover up. So after that, we'll take Q&A.
Okay, sounds good.
Rohit, take over.
All right, I'll start sharing now. Okay, that was a wonderful session, Joe. Thanks a lot for that. I'll just quickly run through a few slides. So like I said earlier, we have Facebook, LinkedIn, and Telegram groups. So if you have any technical questions beyond this webinar, you can always ask the community or answer the community's questions. So Satya has already put down those links. He'll put it down once again. So SQL Maestros Learning Solutions, we have a lot of offerings there. We have the master classes that will start this January 22nd. We have announced 12 master classes on Microsoft Data Stack, including SSRS, Power BI, artificial intelligence, and whatnot. So go ahead and register yourselves for those classes. And we have the SQL Server Performance Tuning, which is a popular course, and now it's coming out in video format. So we will be releasing it soon, but you can go ahead and register yourself to get 50% off on the regular price. And we have hands-on labs. These are a unique practical way of learning. Since you're DPG members, you can access some of the free demos at our official website, that is dataplatformgeeks.com. So before you register, you can go ahead and access the free demos. And we are working on learning kits for the trainers and students based on Amit Bansal's performance tuning masterclass. And if you are in need of SQL Server health check, you can always reach out to us, our official website, sqlmaestros.com, and you can write to us at contact@sqlmaestros.com. So with that, I'm done. Thanks a lot, everyone, for joining us. And thank you, Joe, once again, for that wonderful session. So I would like to point out that we have had participation from 27 countries today for today's webinar. And most importantly, the Feb 2 event. We will be, like I said, we will be launching Data Platform Summit 2019. So if you are in Bangalore, do not miss the event. It is absolutely free, and it's happening at Microsoft Bellandur. So go ahead, and we will be posting a pic of this webinar and posting it tomorrow on our LinkedIn and Facebook groups for your feedback. So expect a mail from us maybe early morning tomorrow, and please do give your feedback. It is really appreciated. So with that, thank you, Joe. You can take questions.
Thank you. And do you want me to just click on the Q&A and then we can go through these?
Yes, yes.
Okay, great. And so a few of these, and anything I can't get into, again, feel free to email that intelligentqp@microsoft.com, and then I can follow up with you. Okay, so Javier, hey, how are you doing? We know each other. Is SSMS 18 Preview 6 where you could get the new execution plan? Yeah, it is in the most, so the question is about the properties I showed at the very beginning. With showing the state of memory grant feedback. It is in a newer version of SSMS 18. And I think I have it in the documentation of the exact one, but it is a preview build. It doesn't mean you can't use SSMS and still get memory grant feedback with older versions of SSMS, but in order to see the new attributes, you'll need the latest preview version. So Javier, thank you for asking that question. Now, let's see here. Okay, Sandhya, memory grant only for sort and hash. For this current version, the big ones that we are focusing on are indeed sort and hash spills. Those are the big common ones. And elaborating on the idea of sort and hash operators, just to notify you when we increase the memory or decrease it, it's at the operator level. So you could actually have a mix in your plan where we're going up and down based on wasting memory or spilling memory across operators in the same plan. Thank you for that question. Okay, and then Sandhya, if a query, and I think I missed one seemed to disappear about CE, but or dismissed. Okay, all right. So if same query or SP executed by multiple users, does it require new memory grant for each and every execution? Okay, so the question here is when do we actually have, I'm kind of restating the question, when do we actually have memory grant feedback come into play? And it is for a cache plan based on the exact, if it's store procedure call or ad hoc script. If there's a match on that and it's the same hash, or the same query hash, or execution of the same object, then that, and that memory grant feedback is maintained with the persisted cache plan, then the multiple users will benefit from it. If there are variations for it, or if you have a situation where it's not parameterized and you get 55 different versions of the same query, but just different literal values, then each one of them will have to learn independently. Thank you for that question. Okay, can you give a value of what the cost threshold of parallelism should be? Leave it at 5. So this is a bigger discussion, not directly related to intelligent QP, but I'll give my brief answer to this. In general, I know that there are recommendations from MVPs about bumping this up. We know that cost threshold for parallelism is based on this cost that is represented from years ago on a machine that no longer exists or is under somebody's desk somewhere. And so we know that if you have a scenario where typically you are firing off parallelism and you don't want to, it's hurting concurrency or your serial plan is more optimal, certainly bumping up that cost threshold for parallelism can be an option. But I've found just in my experience working with different customers that it's very hard to find the right value that is appropriate for all workload characteristics and scenarios. And very rarely do we also see where it's a totally pure design where it's all OLTP or it's all analytic. It's very often hybrid, which means that your requirements around this cost threshold of parallelism can definitely change. There are MVPs with opinions on it. Feel free to check them out. From a Microsoft perspective, though, we're not taking a position on this because we don't. It's not in the space that we want to solve. We want to solve it a different way. Thank you for bringing it up. Okay, batch mode, how many rows per batch? I think it's, it could be around 900. It varies. So it just depends on the specific data characteristics. I think if you find old documentation, I think we used to say 1,000, but, and you can see how many in the actual execution plan, you can see the number of rows per batch. Next question. Missing index should be more intelligent. I agree. Even when existing index is available, we should have it include column. It shows as missing index, should give suggestion to include. I will take back that feedback, and I agree with you. There are lots of ways that this could be better. Thank you for sharing that feedback. All of the query features will be available in all editions. We don't make the final edition determination until general availability of SQL Server 2019. In Azure SQL Database, yes, you're going to see this across the board. But for the actual box product, as we call it internally, for SQL Server, that decision gets made at the very end of the line, just like we did for 2017. Thank you. All right, and then with intelligent QP, parameter sniffing problem will go. During the second execution, will SQL Server detect the sniffing issue and clear it off? Okay, so it will address a very specific kind or flavor of parameter sensitivity. So I would say let's take an example of, and I've seen this with customers before. Let's say every 3 months, a bad plan gets into cache. Let's say they restarted SQL Server, somebody comes in and they test the store procedure, or they use an application with parameters that has an atypical value. And then all of a sudden we have this cache plan with this atypical value that's not asking for enough memory. Let's assume a low row atypical value. Now, memory grant feedback, how would it address that? Well, it would look at it and go, hey, I spilled to disk for this plan. And so for the next execution, add memory so that we don't spill to disk on the next execution. Now, assuming everybody else needs that amount of memory and we're not oscillating between wasting memory and spilling memory, then yes, we address that unidirectional version of parameter sensitivity. What we don't address, though, is if we oscillate back and forth. The overall problem space is still there, where there are scenarios that based on the parameter value, there may be totally different plan strategies that are appropriate. There's a lot of content out there of how people address that problem space today, and there are 5 different canonical areas that people typically use to address parameter sensitivity. But we know that we're just addressing one angle of it. Thank you for that question. Okay, in order to know how much memory a query uses, you need to run a query and see the properties in its plan. Or is there a way for DMV or something like that? Okay, so there are DMVs that can expose information while the query is running. And I believe there's also statistics associated with this in Rowsstore that you could take a look at. So there's a combination of, you can look at the plan, and there are a few different DMVs that you can look at. And if you're unable to find them through search, by all means, email intelligentqp@microsoft.com, and I'll hook you up with a few different options. Thanks for that question. All right, so will Azure SQL Managed Instance be frequently updated with the latest improvements on the IQP? That's the intention. We have different trains that go out as we have new features flow. And sometimes we're out of date, or it might take a little bit based on the train timing, but the idea is that there's overall parity. If there's anything that's more urgent for you and a specific business need and it's related to MI, by all means, please share that feedback. That's always helpful. And then any problems with storage location, that one might be unrelated to what we've talked about today. So if you have another angle of that question, feel free to email that. And if I misunderstood, or if there's more you wanted to expand on. So Rohit and Satya, I think we are right at the mark. So I really appreciate you having me on this call, and I appreciate everybody staying up late for this. Thank you for doing that and for having me.
Yes, pleasure is ours, Joe. Thank you so much.
Thank you. All right.
Thank you.
Have a good rest of the day and good night.
Thanks.
Take care.
Good day for you.
Good day
All
for
right,
you.
take care. Bye-bye.
Thank you.